Hey, what's up, guys? Keep that folder going there. Just doing a sound check, making sure that the music's not as loud as my voice, because, you know, that might happen. Anyways, so yeah. Yeah, let's see what we got. I think we're doing okay. Okay. So yeah, the next thing we really need to do is probably get something to render onto the screen. Before we're actually doing GameLoop, I've got one thing that we need to do. That is actually getting the graphics of the actual J panel, because currently we got this buffered image, but we're not doing anything with it. So let's do that. Let's do something with it. So we need graphics objects, and which call G2 because there's already a G, and we're gonna cast to graphics to actually just graphics. This get graphics. So this is basically calling the method in JPanel graphics. So with this, we can actually start drawing the buffered image that we got going on. So, and then all we need to do is go image and 0, 0. That's the X and Y position. There you go. And that's the width and height of the actual screen, of the actual J panel. Then we need to do null, and that's it. And then after that, we need g.dispose. So if we don't, this is actually kind of important, because if we don't have this, then we just have like this, like caterpillar images of just like one image, you know. Hopefully that was enough imagery for you to understand. So yeah, that's basically it. So basically what we're going to do is we're going to quickly create an image, and we're just going to put it on the screen. Now for us to do that, we need to use this graphic image, because we're actually this graphic is actually drawing onto the buffer image, which this image is actually being drawn onto the screen, as you can see from the graphics G2. So that's how we draw images on the screen, and like shapes and stuff. So I like to do this. It's not necessary, but I don't know why. I just do this. So if G is not equal to null, then draw. If it's equal to null, then don't draw, obviously. Then we're gonna set the color. This is gonna be the background, basically. So we're gonna go new color, and I have a special color that I use. It's like a blue, so it's like the Unity blue, you know, when you, I don't know if Unity has that blue. I think it's a blue, right? So rect, and this is going to be the background. So this is going to take up the whole screen. If we do this, so basically what fill rect does is basically create a rectangle with the X and Y parameters and the width and height as well. So yeah, we can run that, and we can actually see if that's going to be okay. Oh, look at that, it shows you the color. Yeah, so this is the color that I usually take. It's like this blue, kind of like a Unity background game thing. So let's run it, and it should be blue. There we go. So this is the game loop, and we're going to change this. This is where it gets kind of technical and a little complicated. It doesn't really need to be, but it's going to be. So yeah, the first thing we need to do is set like how many times we actually, basically the game hurts. Basically how many times we want to update, and how many times we want to render. So that's what we're going to do right now. So we're going to do final double. Yep. And then we're going to have this in all caps, because usually when you do final things, you put like the variables in all caps to signify that it's a constant and won't be changed. So that's one reason why. And then we have double, and really this is time before render, before update, I'm sorry. So we're going to shorten that to TBU, because I don't want to like write really long names. And we're gonna go with 1,000,000,000. 1, 2, 3, 1, 2, 3, 1, 2, 3. And we're gonna divide that by the game hertz, and you'll see why. So yeah, I want to make a note that the variable means time before render, just for readable purposes. Oh, not render, time before update. And we're gonna make sure there's a space there for some reason. And then we're gonna have a before render. This is like most updates before render, basically. So it's an integer, it's gonna equal 5, and I make a note. Must update before render, and that's that. And then we're gonna focus now on the oh no, we still have to do this. So the reason why I divided the game hertz by like 1,000,000,000 is because we're working with nanoseconds, and so that nano is basically negative 9, right? And 1,000,000,000 is positive, by the power of 9. But hold on, let me just freaking write this first. Nano time. So yeah, so nano is basically, wait, is that right? Yeah, it's basically this. Like that's the nano time there. So, and that would be like equal to like 0.0000, like 9 zeros. Imagine that. So that's what's going to happen with that. So yeah, we're going to do that. Why do I have that? It's just a second here. That doesn't make sense though. You're not okay. Apparently I'm doing this. Last render time, and that's it. We're not going to do anything with that. That's also going to be working with nano time. So we're also going to have, we're working with the render time now. So if we do target FPS, it's equal to 60, so we're going to have like 60 frames. And then we're going to do final double and total time before render. Okay, so 1, 2, 3, 1, 2, 3, 1, 2, 3, and that's 1,000,000,000 hopefully. Target FPS. Let's see if that's 1,000,000,000. And it's 1,000,000,000. Total time before render, and then now we're gonna do the counter, like the frame per second counter, the FPS counter. So to actually count how many frames are being rendered, we actually need a counter to do that for us, and we're going to make that right now. And I'm going to do the last update time. Hopefully that's a 1,000,000,000. And an old frame count to 0. So yeah, hopefully that's 1,000,000,000. Yeah, seems like it. Okay, so now we're gonna do some other stuff. So system, this is actually taking the current time, and then we're gonna update count is equal to 0, of course, because at this point, when we come back to the while loop, we already updated, and you'll see why we do that in just a second. And probably need another one for the last update time, and if that's greater than the time before update, and if of course the update count is less than the before update, and then we can just update. So basically what we're saying here is we keep the current time, we subtract that by the last time it's been updated, which at this point, if this is the first time running, then it hasn't. But let's just say, oh my gosh, there we go. Just like lower that a bit. I don't know if that was any difference, but anyways, so yeah, we take the now extracted by the last time is updated, and if that's greater than the hertz that we actually want, and also if the update count is less than the most update count or whatever, update before render, then we can update. Because if we actually updated it 5 times already, then we can go ahead and render. But if it's not, then we're gonna have to update at least 5 times. So yeah, and this part here is just checking if the gigahertz is on time. Because remember, this is going to be a very low number there. Yeah, actually we can probably just can see if that is what that is. So it's a there we go. Divided by 60 is equal to that. It's a very high number. Oh, did I say low? I did. My bad. It's gonna be a high number. So yeah. Do you know what we also want to do? We probably want to do inputs here as well. Okay, we're gonna leave that as that for now. And we also want to make sure that we can actually get out of this part here. So we're gonna do that way. I'm gonna update count, of course, because we updated. Maybe +1. Now you don't have to do this, but you can. It's just for rendering purposes and updating, but really it's for rendering as well. Just to make sure that happens. So yeah, and we also want to input here as well. We want input to be continuously checked for. Is equal to now. You know, of course, since we render, we do frame count ++. This second. Okay, 1 2 3 1 2 3 1 2 3. Okay. Okay. So this is actually the frame counter. So we don't want to like freaking. We don't want to like keep calling the. We don't only keep outputting what is. We don't want to keep outputting the frame rate. We just want to output if the frame rate has changed, basically. So that's why we have the new frame, or not new frame, but we have the old frame count and the just regular frame count. And of course, to make that if statement true, we just do that. And then here, we got to put the frame count to 0 again, so we can continue incrementing and not giving us observed times, you know, like billion frames per second or something. That's a little absurd. And we're gonna let the CPU breathe, but we're gonna actually make this method first. Input. There we go. Okay, so we're gonna make the CPU breathe, because even though we're doing all this restricting to like the render and stuff like that, we still need to let it have some time to rest. Alright, is that a method? Not a method, is that a variable? Last update time is less than the TBU. This is now. Then we're going to do thread.yield, oops. And then we're going to do a try catch. And we're going to just catch an exception. System. Oops. Error. We can just do that, and that'll be good enough error statement there, just to understand what's going on. And then we do thread.sleep, and we can just sleep it off in one millisecond, because why not? And then at the end we can do now is equal to system time. And there we go. So yeah, even though we do that in there, we can just whatever. So yeah, that's the game loop. So yeah, in Word. Okay, I guess it's like grammatical error, but yeah, basically a game loop. What we have to do to actually find how many ticks or how many updates have gone by, we just get the now, and we subtract it by the then, so we can get the time that's like the time that it's been like passed basically. Then we say, oh, is that greater than how many game hertz we want? If that's true, then we can just update and stuff. And here we're just making sure that statement is true. So yeah, or we just redoing that. Yeah. Okay. Never mind. Yeah, it's not bad. So yeah, that's the game loop. So we can run this. I think it works. If it doesn't, then that sucks. No, it works. It works. As you can see there, 57, but then the frame count changed and it turned to 60, and right now it's 60 all the way. So that's cool. That's what we got going on right there. How much was that? That was 17 minutes. Pretty good. I like that. So that's the game loop we're gonna have. I didn't explain a lot because really it's a lot. Not really. I just don't like doing this. Game loop is fun and all, but man, I actually like talking about like different types of game loops, so we can say that for now. We can like end like at 19 or something in a minute. So there's different types of game loops. This is a fixed time game loop. There's a variable time game loop. There's like fixed variable time game loops, like hybrid of the both, which is pretty cool. The reason why we're going for fixed time is because we're not really particular on the speed, and plus this is a personal project, so we don't have to deal with like, you know, running this on different environments, on different computers. And like if we do run this on different computers, maybe a variable time loop would be better. So like, because on different computers your game will run differently, and maybe there might be lag, and so if there is a lag on different computers, then we can have a game loop which can count for that. So for example, if there is a lag, we can actually in the render, and also in the update, we can actually give it an argument, like for example like speed or whatever, or like delta. That's what most people do, but basically what that does is to deal with speed. So anything you're dealing with speed with entities and with any objects that are moving in the screen, you would times that by delta or by the speed, so that when there is like lag, it won't be noticeable to the user because everything is there's like a factor accounting for it, accounting for the lag. So yeah, that's basically how the variable game loop works. This is a fixed time, so we don't really deal with that as much, or like at all really. But there's also hybrids, which is really cool. So this is really dealing, the hybrids is really dealing with the issue of updates and renders. Like sometimes the update might update like in between renders, so that might cause problems with like bullets physics and bullet time. So like for example, in I don't know, in some games this is actually a networking issue also, but we might not deal with networking in this game. But yeah, anyways, so like networking, or like when you have a multiplayer game, sometimes it feels like you shot first. Maybe you did, but what happens is, okay, let's say a scenario. You see a guy, you're about to shoot him, but you don't see, you didn't see him turn around or something. But then all of a sudden you're dead. Like you had no. It's kind of like that's like, I guess that's a really network lag. But anyways, okay, let's say you have two people facing each other and they both have guns and they're both aimed at each other, and all of a sudden you're dead, but you didn't see like a muzzle flash, or you didn't hear the bullet, or the bullet leaving the chamber or whatever. So that might be with the issue of the updating actually happening before render. So it updated and it presented that you were dead, but the rendering didn't show that because it updated before it rendered, right? So is that right? I think that's right, or the other way around. I don't know, but that's basically it. That's what the hybrid is trying to account for. So it's trying to make sure that both the update and the render are happening at the same time, and they're happening together, and they're happening in synchronization. Update time, the fixed time, actually, we kind of doing this too, but we're updating 5 times more than we're actually rendering. So I mean, it could go either way. Plus, it's not like we're not doing CS:GO here, so we don't have to worry about that. So yeah, that's basically it. All right, goodbye.